Okay, perfect. All right, thanks for joining everybody. And today we are covering a very exciting topic, which is developing a web app using Plotly Dash. And yeah, so we have a lot to go over today, and hopefully you're excited and you have your Python or anything you develop your code in, such as VS Code or PyCharm ready. But because of the fact that we only have 1 hour here, it's not meant to be a workshop where everybody is able to follow the coding, but we will definitely post the code onto GitHub and share the GitHub repo with everybody. So if you're interested in the background code or you're interested in following along, then for sure check out the Slack channel after the presentation. So let me just get started in this. So this workshop, we're going to talk about building a web app using Plotly Dash and integrating machine learning model in it. So the agenda for today is, first of all, we're gonna have a general overview of creating a data science product, which is what we do, or like what I'm used to do from the start to end. And the second part is to show exploratory data analysis code snippet and also show the machine learning part of the code with you. And then Michael will be introducing how to build an app in Dash. And then finally, I will do a demo app that we developed for this presentation. So about this app, it's actually a data set that you can find on Kaggle. It is the coronavirus COVID-19 data set that's pretty popular on Kaggle. And in the first initial planning phase of this app development, basically what we plan to do, our vision for this app is, first of all, you're going to be able to visualize part of the visualization part of the app is you're going to be able to visualize how many cases in each part of the world on a daily basis. So to do that, Plotly actually has this mapping function that you can plot a world map, and then you know which data belongs to each of the countries, and then from there you can visualize the data that way. And then the second part of this app, the intent for that is basically, let me just annotate my screen here. So yeah, the intent for the second part of the app is we're going to build a prediction because within this data set, we actually have data from all the way from January of 2020 to May of 2021. But what happened after May 2021? So the intent of the second part is to use a machine learning algorithm to predict any of the trend for the cases, whether increase or decrease after May of 2021. So it will be a line chart that kind of looks like this. For example, for a specific country like US, the x-axis is the date, and the y-axis is the cumulative number of cases. And then maybe on top here, there's a text box where you can actually input how many days after May of 2019, which is the end of this data set, that you want to predict. Let's say you want to look at the next 200 days. So this graph is going to be able to show you, from May of 2021 all the way to December of 2021, basically, that the trend it predicted from the ML model. So that's the intent of the second part of the app. And then let me clean the annotation here. Okay, yeah, so without further ado, let me just dive into how it was actually built. So this is a general overview of what I did when I first took the data sets. So first of all, obviously, I had to explore the data because I don't know what all is in the data set. Sorry, does anybody have a question? Or if not, please, I would ask you to mute yourself. Okay. So yeah, the first step would be exploring the data, and I did that in Jupyter Notebook, which is a really convenient Python-based application where you can run each line of code. And then, yeah, so it is very convenient and it's very good for exploring your data. And then after exploring, you're going to find out that because this is real world data, so it's not going to be perfect. A lot of data is going to be null or zero. And so you have to clean your data. And then after the exploration phase of the data, you can choose to do different things with the data, i.e. building visualization, or you can dive directly into machine learning part of things. So building machine learning model and training the model and make interesting predictions with the data set. So to build visualization, two basically libraries that I used in Python. One is Plotly and the other is Matplotlib. They're all really powerful visualization tools that you can use in Python. And for the machine learning part, the model I selected was the TensorFlow Keras model, specifically sequential model, which applies really nicely on time series data. And then after you selected the model and trained the model, the next step would be evaluating the model. And if after evaluation and fine tuning, just going through this process of training model and evaluating model, you end up getting a good model that meets your expectation in how well it predicts, then you can actually save the model and then put it into production by building an app. So this is the general overview of the workflow. And then, so specifically how each of the steps is done. First of all, I would dive into this exploratory data analysis part. And then I will also show you some of the code that I did for the machine learning part of things. So first of all, let me ask, up until this point, does anybody have any questions? Okay, perfect. So yeah, for the data analysis, I didn't use much other things than pandas, which is a data frame manipulation package in Python. And it reads in the CSV file into a data frame, and then you can do all sorts of different manipulation to the data frame. But first of all, this is just an overview of what all is in our data set. So as you can see, we have observation date, which is which basically you have data for every single day, and you also have province and state, country and region. So for country and region, you're able to find, you know, China, Ukraine, Netherlands.
Sorry, Hannah, excuse me. Could you please zoom in a bit?
Okay, yeah, for sure.
Perfect, thank you.
Thank you.
Yeah, great, thanks.
Yeah, all right. So for country and region, you have most of the countries actually in the world. And so this is, I would say, is a pretty good data set, and it's pretty complete. And not all of the countries have its associating state though. So that is something that we have to pay attention to. And that is primarily why I decided to plot this data in terms of countries instead of the provinces, because we don't actually have that complete of a province or state information. And then other than that, we also have these cases, these 3 columns, which is confirmed cases, death, and recovered cases. And after further analysis, I realized that this data is organized in a cumulative way. So it doesn't tell you for each of these days how many more, like on a single day, how many confirmed cases you have, how many deaths you have, how many recovered you have. It tells you a cumulative trend. So this is basically what the data set is. And later on, there's just more exploring to like how many good data we actually have. And obviously there are a lot of null values. So dropping the NA is actually very necessary. Yeah, so, and then basically moving forward, how you can go about plotting this this map, which actually looks like this if you're curious. And there's a slider at the bottom that you can slide to different days, and then the color is going to change based on the number, and you can have you can see the legend on the right hand side here. So how you can plot this is Plotly actually has this choropleth map within its Plot Express package, and it takes something called ISO code, which is a short form, the country code. For example, for Canada would be CAN, for United States would be USA. So it takes that, and then on its back end, it probably runs a GeoJSON file that has the information of what region, what the ISO code belongs to, which polygon here. So that is how you're able to plot this map. And then yeah, so basically I had to, based on the country and region column, I had to essentially add this other column called ISO code. But yeah, this other than that, this data set is pretty straightforward. The only caveat would be, because it is a cumulative data set, if you would like to view the data on a daily basis, then you have to do some manipulation to actually get the daily information by country. So that would be the only manipulation that is done here. And then moving forward, I would go into the prediction part of the analysis, which, okay, I see a hand up here. What's up, Daniel?
Just a quick one. Please, what within the choropleth method used for the PX, which parameter adds the slider to it?
The slider actually, you can just add in this parameter called animation frame. And as long as you have your datetime in your data frame, then you can select that column, and that is going to be your slider. But make sure before you do that, the date has to be sorted. Otherwise, you get like really weird days order. But yeah, other than that, is actually pretty straightforward. Okay, yeah, going back to this prediction part. Yeah, so basically, the package I decided to use was for the data frame transformation, I use scikit-learn standard scalar, and for the actual prediction, I use Kara's sequential model, and 2 layers. One is dense, the other is LSTM. So here, same idea, reading in the data frame with the column index being the observation date. And then, so because this is just for a demonstration purpose, I only use the data for US. So the data from US, so for country and region in US, and then, yeah, basically after a bunch of manipulation to the data frame, I was able to plot this, which is all of the data that we currently have from January of 2020 all the way to sometime in May. So as you can see, the cumulative trend is that the cases in the States keep rising, and there's a period of time when it rose very drastically each day. And then using a standard scalar, what it does is basically it standardizes your features by removing the mean and scaling it to unit variances. So basically, as you can see here, this is essentially the equation it applies. The number after transformation would be your actual data minus the mean and divided by the standard deviation. Yeah, so for train size, I decided it's going to be 70% of the total data, and test size is 30% of the total data. And then, yeah, so for the sake of time, I wouldn't go too much in depth of how the train test split is done, and it is actually pretty straightforward, and why these 2 layers were selected. But if you're interested in this, we can definitely catch up offline, and for sure send me a message, or if you're in the Slack channel, feel free to post any questions you have in Slack, and we can definitely give you better explanation. But basically, after building this model and training it with 60 epochs, this is basically the end of the model. And then I was testing the performance of the model by calculating the root mean square error. And I was also trying to visualize the result of the prediction, which actually, as you can see, is pretty good. Fairly close to what the actual data is. So the orange one is the prediction, and the blue line is the actual data. And then, so here, this is a function that I use for this model to predict future data. You can basically put in your parameter as the future days parameter to however many days in the future that you want to predict. But of course, the further out you predict, the less accurate it is going to be. And then, so here to test this model, I decided to predict 200 days out from May 29th, which is the end of the data set. And as you can see, the result shows here, which looks fairly, promising and believable. But obviously, we're in October now, so if you're actually interested, you can go check what the actual trend is and compare it with the model prediction. It'll be something interesting to find out, to see how accurate this model is. But basically, after you have your model, you can actually save it in your directory, whichever directory that you end up deciding to put your web app in. And then eventually you can read in this model this way and then use it in whatever application you decide to build. So yeah, here is a basic overview of the workflow here. And let me move on to the second part. Any questions up until this point? Okay, perfect. So the next step would, I would pass it on to Michael to introduce Dash.
All right, guys. I hope that was not too much to take in. I would try to make it a little bit light here on the technical piece. I have some presentation that I've put together to really give you guys a cool feel as to the underlining engine of Dash, and to discuss a few things here. Just give me 1 second here. I don't know. Where's my mouse now? Oh, can you guys still see my screen though?
Yes.
Okay. Can you stop me from sharing 1 second there? Since everything just froze. Just stop sharing now. Just stop sharing as a host.
Sorry.
Oh, okay. I think things are back now. Okay. All right. So let me reshare my screen. Just 1 second. Okay. Stop sharing, then share again. And okay, so cool. So this is what I wanted to do. All right. So can you guys hear me good? Hello? Can you guys still hear me good though?
Yes, loud and clear.
Okay. Nice. So we're going to be looking at introduction to Plotly Dash, and just to have, I mean, Hannah, thanks for taking us through those details, and probably a perfect handshake transition on this presentation. So I'll be taking us through introduction to Plotly Dash. Sometimes you just hear it called Dash, not Plotly Dash. The reason why you see Plotly Dash is because Plotly developed Dash, and as a matter of fact, Dash actually runs on Plotly. So we discuss those and see how that can benefit your understanding to see Dash from an application standpoint. And some weird things are happening on my screen here. I don't know. Just 1 second. Can't control my screen. Okay. So okay. That's I'm not sure what's going on. My screen is frozen. Can you guys still hear me?
Yes.
Oh no. Screen froze.
Oh,
So
now it's moving.
oh no. I really don't have an idea what's going on. Okay, so let me try something again. Let me stop sharing the screen. We're going to stop and try again. Perhaps this time around it's going to work. Okay. Okay, then I'm going to swap this. Nice. Okay. So we want to do everything in Python as data scientists because it gives us the leverage to write things natively. Because if your development language are very close, how fluent your application development would go will also be enhanced. So Plotly actually see that need because data scientists are technically not going to be developers. What we really still need to productionalize any of the data concept that we have actually proven. Because most times the way it happens on the data science side is that you want to empower a use case for business use, and you get data, you do your notebooks just like Anna have shown, but those notebooks are not super exciting per se for decision makers. So you want to really move the product that you have come about into a form of a dashboard, and that's where Dash actually got its name from. But it is more than just a dashboard because it gives you the full capability of a web app. So I'm going to step into it very quickly. So what are web apps and why do we need to use web apps? Web apps, I think we are largely in the areas of web apps, and now web apps are even very much, transitionable into mobile apps. So you see some websites, when you open it on your phone, it looks typically like, like a mobile app, because, there's a cool transition between web apps and mobile app these days. So web apps generally present an application running on a remote server. So usually, if you think about traditional way application runs, you will install them on your own local machine, on your physical machine. But web apps present to you the opportunity for you to visit a URL, and from that URL, an application running on the remote, server is exposed to you. So you can interact with the application, you can exploit or explore the functionalities that the application actually presents without you really hosting the compute. So that makes it really very cool. It's an easy way to share your works. Even for some of us that are still trying to aspire to get a data science position, you probably would find fun in showing off the kind of skill you have if you build a good number of web apps. To build web apps, usually you need something that will handle the back end. Most times when we talk about the back end, we're talking about things that store inputs like the database. You probably also would need something that manage a couple of transaction with different agents, because when you're interacting with the web app, you're actually interacting with a web server that is really going to respond to your request. So there's a back end part and there's a front end part of a web app that really shows you, give you the look and the feel. How the buttons look like, how the page look like, the color stuff. Those are the front end. Storage is big because sometimes you may need to put in some data, you may need to generate some data. Those are actually stored also on the back end. And definitely also there's always a server. Just know anytime server is being mentioned, don't let it confuse you. What that just means is a computer. Server is a computer serving an intention. It could be it could be to store, it could be to compute, to do stuff. So server generally are just computers. And they are computers that you may not be able to see physically, but they are somewhere actually implementing some of the requests that you're actually asking the client to do for you. So security is always a part of web apps that is key. But one of the ways that cloud evolution has really make life easy is that we can implement some of the security at the cloud level. But most times when you really want to think about security big time, you probably would want to stay on-prem. Um, that being said, there's also access to, there's also need to control access. So when you develop your web app, do you want everybody to have access to it? Everybody come in and they just go straight to that URL. It doesn't stop them at all. Just go straight to the application and they can interact with it. Or do you want to put some sort of authentication so that you can always allow those you want to access your web app? So the same way the cloud paradigm have solved a lot of issues. For instance, in Azure, you have the Azure Active Directory, which is really a big, win or a big step forward in really removing the pain points around authentication. So authentication is really just how you really manage people that can visit or access your web app. Yeah. So what are we doing here is that here we are going to be using Dash for front end and Python for back end. So all Dash by itself is exposed on a high level in Python. So we're going to be writing everything in Python, but under the hood, there's some other language interpretation happening under the hood. But Python is the paradigm we're going to be coding in, and Dash is going to be like our front end framework that will be really giving us all the look and the feels that we want to really make out. There's no heavy usage of storage, for instance, in the application that Anna is showing. So we'll probably not talk so much about databases, but it's very important to understand how to couple your web app with databases, because most times, of course, you may have some transactional, some sort of, transactional triggers that need to keep records, save records, fetch records, and whatnot. So the database will be necessary. So what I'm trying to step you guys into is for you to think of the architect of a web app. So a web app will have a front end, a back end, a storage, a server. So the server is the one that is actually responding to the client request at every point in time. So that sounds like a lot, but I think it's actually very important to mention this, not just to talk about web apps and you're wondering what web apps are. Now, what is Dash? One cool thing about the kind of time we live in now is that things need to be open source, for crying out loud. I can't be paying for back in the days where you want to use stuff, you have to have license, you have to have that. But now Python really opened a lot of stuff up for us so that we can have open source. Now, keep in mind, Dash exists in two forms. There's a community version, which is usually free, which is probably the common trend for a lot of applications these days. And there is an enterprise version, which is really an enriched ecosystem where you can develop, you can deploy at the same time, all in that compact ecosystem. But what we're going to be looking at today is just going to be the open source end of Dash, which is the community version. So it is really a package that is written in Python, but it's an abstraction over React.js and Plotly.js. React is the one that gives it the reaction, the responsiveness. The Plotly.js is the one that gives it several visualization components and whatnot. The application you develop with Dash are very modern, they look very good, and they're highly interactive. Just like the design paradigm in React, it is all component based. That is, you design your application or your web app in components. So you're going to have several components that you can interact with, that you can tie to different actions. And we're going to see some of those concepts very quickly. I'm trying to run so that I can really make sure that I keep everything to time. So good news is that you don't need to write your own fundamental HTML codes. It comes with loads of pre-written HTML components. In fact, there's a full-fledged package called the Dash Bootstraps, which is what Anna also will be demoing and showing you. All what she has developed, she's developed it using the Bootstrap, which is cool. The Bootstrap is just helping you bundle some units of a front-end app application that you can just pick up, modify a little bit, and use it as it is. So it gives you that feel to really have the impression that it's very easy to develop web apps. So the cool thing about the HTML components, which we'll get into, is that once you hear HTML, it's really about the orientation, the content of your page, how you structurally put the page. And the CSS part is just the styling part, which is like the color, the feel, the look, and all those stuff, which is really a very important component of frontend. Now with Dash, you don't probably need to worry too much about this if you're building a very basic app, because we are data scientists, we probably don't want to get deep into all of these and start writing complex CSS or whatnot. What Dash does is that it just expose a keyword. With that keyword, you can control the color, you can control the feel, you can do a lot of stuff that you really like to see in your application. Now, I'm going to say, why do you need to use Dash? Number one, isn't it cool for you to develop your front end in the same language? And yes, that language being Python. You've written all your Keras or your sequential model or functional API, depending on what paradigm of Keras you're really coding in. You did all the stuff, train a model in Python. Now it's time for you to really also deploy the application to a product using Python. That's so cool, right? Another thing about Dash is a low code full stack ecosystem. What that means is that you don't get to code things from first principles. You're probably not going to be writing, like I said, your own very fundamental HTML stuff, but you have HTML component already. So it's really shortening your turnaround to be able to deliver an application. It's easy to deploy, and you can share what you have done. Thousands of apps have already been developed using app. There's a great resource that I'm going to point you all to. I think that's the best way for you to really get into Dash and start becoming confident so that you can build very complex application out of it. It is called the app gallery. You're going to see a lot of projects already developed, all the code open source. In fact, in my previous role, when I was in Exxon, I developed a app, and it was majorly in my attempt to try to clone one of the application that was developed. And I saw a lot of stuff and a lot of tricks, and it was really cool. So the community for Dash 2 is very active, and they use Discourse. You can really jump in there, ask questions, and sometimes you get some very good Samaritan that can go out of their way to help you understand what you do not. One way to really get good at this stuff is for you to build application, build application, build. And very soon you're going to know all the tricks. It's really good to build all of these applications. Anything, any idea you have in your mind, you probably want to see it work. Now, I'm going to do something here now. I'm trying to get to the anatomy of a Dash app and show you how you can see a code and you can really interpret it. Because one of the things that get people, that put people off is that when they see a line of code, it's like, oh my God, what's this saying? I can understand import number as NP. I can understand import pandas as PD. I can understand, import sklearn from sklearn, blah, blah, blah. I can do, but now you're taking it to another realm. So let's look at the anatomy a little bit here so that you definitely will be very familiar when you see a snippet of a Dash app. You can really segment it and say, oh, this is what this part is doing. Oh, this is this part. This is this part. I guess you're going to agree with me that if I want you to identify humans and you can really see the head of a person, you say, oh, this is the head, this is the body, this is the abdomen, this is the leg. You feel more comfortable, like something that is familiar, right? You probably will want to chat with that person. But if you don't see what you expect, you don't know where the head is, you don't know where the hand is, I assure you that you're going to probably be very frightened. So that's why a lot of people get frightened when they see a dash piece of code. So let's try this. First of all, you need to import the necessary modules. Of course, that is only after you must have installed, Dash. And it's easy to install. If you are using the pip package manager, you can just do pip install Dash. It's going to pull some other dependencies. Be ready to have a truckload of other dependencies though. There's a reference link here. Hopefully this slide is going to be made available. You can follow the link and see how it does look like. So let's see what that looks like. You're going to get that, and it's going to look like this. You're going to import Dash itself. There's something called the Dash core components where you can actually, fetch items like, radio button, input. You can put, check boxes and all those things. All those are available in your toolbox. That toolbox is called the Dash core component. So you want to bring this DCC in so that you can have it available and you can use it to instantiate any component you may want to use. So in your app design, maybe you want a top right part of it to carry an input. So you're going to instantiate DCC up there to really present that component that you need, to empower maybe users to interact with your app at any level. So it could be an entry input box, it could be a button, it could be, so those are all locked up in the DCC component. Then you have the HTML component, which is really very crucial. HTML is what you use to define containers. So we're going to see it really, I'm going to really dissect this in a lot of detail so that you can envisage how all these components works, and you can start probably be very confident about how you can build an app that, you can manage the structure, you can manage the positioning of different components within it. And we have the Express package, which exposes a lot of visualization, functions, like you want to plot a bar chart, you want to plot Hannah showed you that she actually plotted that map using the PX class to really call different method that will present different visualization. And it's not probably strange for you to see pandas there. Then the next thing is you need to instantiate the Dash app. So when you bring this in, you need to then create the app itself. So how do you create the app? One of the things the way you commonly, and all these things I'm showing you, you're going to see it in typically any Dash application. You need to instantiate the app. So how do you instantiate the app? You just call dash.dash. So there's a dash method in the Dash class that you can pass in some keywords. Sometimes, of course, is either this or this. You can just leave it up and put the name as done name, right? Or you pass in what is called an external style sheet. That external style sheet is just a template that will have predetermined the color of text. So if you type anything in your web app, it's going to be red. It has already pre-designed everything. It has come up with a template for everything. If you're going to come up with a button, there's going to be a field, color, and look for that button. So you can actually use all these prepared external style sheets. They are available on a content delivery network, meaning that you don't really need to put them on your local application directory. They are served readily from the external source. So once you just, of course, use this keyword external style sheet and you do dvc.themes.bootstrap. The Bootstrap is the name of a team. For instance, there are several teams that you can use. Cyborg, a lot of them, Fire, and all those. You can always use them. DBC is a dash bootstrap component. It's not imported here, but you need to import it to use it if you want to go by the second line. But if you want to go by the first line, which is the basic one, absolutely, that just really would be very like default dash form. So the text will not have been really styled in any unique way. It would just be like plain vanilla dash styling. So now let's grab some data. This is probably not going to be strange to you. Just a pandas data frame that is carrying 3 columns, essentially fruits, and those are the entries under the fruit columns. Amounts, those are the entries. Cities, those are the entries. So we just have a data frame here that has 3 columns and the respective entries, right? Nothing strange. We're just converting a dictionary essentially to a data frame. Then we would like to show some sort of figures. Now, we have the luxury to use Plotly Express, so we don't need to use Matplotlib. You agree with me, Matplotlib is probably not that fun. Doesn't look like very sophisticated. It looks really like researcher stuff. But here we want to catch the attention of business decision makers. We want them to see cool charts. So we're going to use the PX. So I told you that the Plotly Express has a lot of other functions within it, or method that can allow you to plot. You can do px.bar, ps.scatter, ps. A lot of histogram. You can do a lot of stuff that you can plot here. So so px.bar, then you put in the data frame, kind of very similar to what you would think of when you are thinking about Seaborn, where you put your data frame, then you specify the X, you specify the name of the column, Y, you specify the name of the color. Then if you really want to then plot a third dimension in color, you can really make the color to be equal to the value of another column, and you can group those bar charts together if you want, or you can really leave them to be separate in the first place. So we're already building a app, whether you believe it or not. There's something is coming up out of here. So now this is where I wanted to pay a lot of attention here. I think if you catch this, then you'll have gotten the message. So after instantiating your Dash app, you want to serve it now. This is where you want to build that app and make it really work. Now, one part of the app that you have instantiated that you need to supply your application to is the app.layout attribute. The app itself will be a class, then the .layout is an attribute. That app.layout is waiting for you to provide an input to it. So when you provide an input to it, that is what the server is going to display when the port or the URL is actually visited. So here we want to design an HTML container for our application. When we design it, we throw it into app.layout. By the time we serve that model, by the time we serve that application, we're going to be seeing all the content we have in app.layout. So app.layout is very crucial. That is where you supply, that's the entry point, so to speak, of your application. So let's see, how do we do it? We're first of all going to do something. We're going to define app.layout, then we make it equal to some sort of HTML. So here we have the HTML div. Now, what's the HTML div? It's just a box. So this is what happens. It's going to create a box because you have called the HTML div. The HTML div has several properties. It has ID. We'll still discuss that concept of ID. ID is just a unique identification of any component or any Dash object. So every Dash object you have in your application will have a unique name because you may need to refer to them and give some triggers to them. So if you don't have a unique name for them, then that's why Dash will always give you error if you use the same name for different components. You always give you an error because that's the only way it keeps its integrity to know what you are speaking to per time. So you can see, so once you have app.layout and you actually assign this HTML div to it, what it does is that it instantiates this kind of rectangular box, which is equal to the whole space of your screen. Then what do we want to do? We want to put things inside this. So we want to put stuff inside this box now. So how do we do that? We can then put a couple of things as lists. For instance, we can put an H1 tag. An H1 tag is relatively the largest, text size that you see. So once you put an H1 tag, let's see what the result will be on the right. So what it's going to do is it's going to definitely put another box within that major box, and it's going to name it hello dash. So your children is actually what will be displayed in this box. Then after that, we want to see this major div, which is the blue one you're seeing here, can actually carry a lot of stuff. It can be the carrier of all the other components inside that dash app itself. So the next thing we want to do is that we actually want to display the children of another div. So we want to put another div into this main div. So let's see what that looks like. It's going to be like this. It's going to look like this, and it's going to just be like a regular font size. So here you have another div inside the major div, and you can see that they are stacked horizontally on each other. If you want to position them differently, there's a keyword that we can present, for instance, to reduce the size of each of them, to stack them horizontally. We can do all those, but I'll just take this basic part. So you can see the big container, how they carries this smaller container, then we have this other container. Now, let's see, what do we want to do next? We want to actually put a figure there. So this figure, you can see DCC is the toolbox where you have several stuff. You have graph, you have buttons, you have checkboxes, you have a lot of stuff. So we are using the graph part now. Now, this graph is right now a placeholder. It's just a placeholder, and the name of the graph usually is a good thing for you to give name to every of the components you have. So the ID is the name, and that's going to be unique here. So what we are trying to do here right now is to make the ID of this graph object example graph, right? Then we supply the figure object as figure. So it means that this graph object is going to be listening for what is called figure. So it's going to be looking for figure. Don't forget, we have already defined figure. So if I can quickly go back, we defined figure here, right? So you can see figure. This is, oh, let me see if I can use just 1 second here. I'm running out of time, but I hope it's still making sense to you guys. But let me quickly see if I can get this. So you can see this figure object here is what we have already defined here. So in essence, so what is happening is that we are now actually creating some sort of components that would receive that figure that we have plotted. So this DCC has this keyword called figure that can receive anything you have plotted outside of it. So we have plotted something outside now. We want to assign it to this figure. Bang, there we go. It's going to display this figure. So this is the figure that we have plotted in the prior line of code, and this is essentially a preliminary dash app, and this is how those layouts work. Now, whether you like it or not, a dash app is actually a combination of different divs, components, and whatnot. The interactive part of it, this is the display part, is the callbacks. So that's why we're going to talk about callbacks very quickly. And if you understand callbacks, you are good. You can develop very complicated application, because what callback does is that it listens to a particular object, which will be the input. Now, when I say object, think of object like anything at all. It could be a button, it could be a field, it could be a checkbox. So anytime something triggers on any of those objects, a callback will trigger. So let's see, a callback is actually a wrapper function. So what that means is that it's a function in itself that, just 1 second, I take my time. Okay, so Anna will take you guys about callback. So let me probably jump on this, but I'll just quickly talk about the way you should think about it. It's a wrapper function. It has an input object that it listens to. It also monitors the state of that input object, and it's going to really take action and display its result in an output object. So it's like you tell the callback to listen to, maybe for instance, to watch the door. If anybody come in there, take this action. So that's what the callback does. So it just listens to any change. And it performs functions, renders the output in a figure. It works largely by IDs and properties. So you can use callback to return the property. You can use it to return different different part of a figure, so of different part of an object. One concept that is very powerful that you would need to learn a lot is the hidden div. Although there are some other ways around it, but if you want a page to reload anytime you visit or trigger it. There's a concept called hidden div. I'm not sure if Anna used any of all those concepts, but it's really a very powerful concept when you're designing a dash app. So you can write everything in a Pythonic way, it's super cool. Now, I think that is everything from me. Just one more slide, I think. Yeah. So let's look at how you now save the application, right? You have actually do this, but now you want it to be available in a URL. All you need to do is just, in a Pythonic way, the way you monitor how to run a script. If you write a Python script and you want to run it, you just ask if the name variable is equal to main. And if the name variable is equal to main, then you want it to take an action. So you always see this in most dash app because it is running as a script. So you're going to check if the name variable is equal to main. What this is just saying is that I want you to run this current script. That's just a literal way to put it. Then it's going to provision it on the server. It has several keywords. Probably, of course, you can put debug equals to true. That just helps you see the traffic that is really eating your web apps. If you want to really drill down or not, you can put true or false. And that's it. You can build a web app this way. I think the most important thing to understand there is how to use your HTML components. Think of it as, several types of boxes that are coming together to present a feel and a look of your application. I use callback to really enhance the interactivity. So over to you, Anna. So let's see what Anna has to really demo for us now. Hannah, over to you there.
All right, thank you, Michael. That was a very complete and wholesome explanation of Dash. So now I am just going to show you what I've done and maybe put some of what Michael said in his slides into more perspective. And first of all, Michael talked about how Dash app is really component based. So here you can see after you initiate this app equals to dash, you can basically put in an external style sheet that you're using, which is the Bootstrap in this case. And the theme I was using is just Bootstrap. So basically, all of the features in this web app I built was component based. So here is a navigation bar component, here is the radio items component, and here's the switch component and the body component. And then after that, let's say I wanted to make a line graph, then there's a line plot component where Michael also showed you that, there's a dash core component, and then you put a graph within this component, and then you give it an ID. Here is called line chart. And why is this ID important? This ID is basically, just now Michael talked about the callback function. So how the callback function will be able to listen to any of the user input and reflect the change in your actual app layout is by referring to this ID, right? For example, here, the radio items is basically a list of selections. And it has an ID of radio item inputs. So basically, when later on in your callback function, you would be referring to this ID to listen to what the user is inputting in this component. And then what it affects is basically this graph, which you would also be referring to by using the ID, which is basically here, line chart. So moving down, so this is basically the callback. Callback is a wrapper or a decorator for the function. And once you have this callback decorator, you put in the ID, basically. This is the ID, and this is what type of object it is. So in this wrapper, your output is the map, which is the ID for the map that I am going to plot. And your input is the ID radio items inputs, which you saw just a few seconds ago. And you also have another input, which is this switch input. And what does that do? I will show you the actual app. So here is the radio atom input. And then here is the switch input. For the radio items, basically what it does is, you remember in the original data frame, there were 3 columns: confirmed, recovered, and death. So here you are able to select which one you want to view by selecting these individual items. And then the toggle here, what that does is, if you remember what I talked about before, the original data frame is ordered in a cumulative trend. So if you don't want to see it in a cumulative way, but rather you want to see it in how many more confirmed cases there is, or how many more recovered cases there is daily, then you can switch this toggle back, and basically you're going to be able to see the individual days update in this map. Once it loads, we can see it in action. So yeah, basically, if you drag this, you can see like the different updates of areas. Here is Brazil, the States, Russia, India, which really made sense because these were the really bad regions in terms of number of cases. Oh, this is recovered, but in terms of confirmed and death, I'm sure there are also a lot of cases over these parts of the world. And so here, this is basically the machine learning prediction in action. In this box, you're able to put in how many days, enter the number of days between 5 and 300. So basically, how many days after May of 2021 you want this model to predict. I would just put in 100 right now and wait for it to update. If this is still connected, let me see. Right. Yeah, I don't think yeah, it's currently updating. Just give it a few moments. Anyway, so as you can see, by using these callback functions and by using Plotly Dash, really, it's a very simple coding. Oh, it just updated. It was December, now it's October, and this is the trend. And again, you can check this against what actually happened and see how well this model is performing. But yeah, this is basically what Plotly Dash can do. It gives you the flexibility of building a front-end app with Python and very light programming. As you can see, if you were to do this in React, I'm assuming it would be like at least double the lines of these codes. And also you have the ability to incorporate machine learning models in these apps you build. So yeah, thank you very much for listening. Do you guys have any questions? Okay, perfect. If not, then thanks, Michael, for presenting introduction about Dash. And I just have a quick announcement that next workshop was originally planned for October 22nd, which is next Friday.
I think there's a question there.
Oh, okay. There's a question. Yeah, go ahead.
Okay, sorry, I came in late because of the time difference, so I'm at 12 o'clock here. Okay, 1 o'clock here in the night. So yeah. So my question is because I have a project that I just finished working on, so I wanted to deploy it to the web, and the kind of outputs that I have is kind of control charts, and also charts that shows the predicted trend against a major trend. So I'm still trying to learn how to manage this. So in the dashboard, there's a way of being able to plot any kind of graph, or do you have any API that you can call to bring out specific graphs, or is it your code that is going to output that graph? So I just want to understand that.
Okay. Yeah, so if your application would be showing some sort of visualization based on user input, it depends on whether you need some data to present what the user is going to see, or on the fly, if the user puts in some parameter, there is a part of your code that generates a function and gets you the data that will be illustrated. So depending on those two use cases, you may need to have a means of persisting data. So what that means is, let's say you have, I don't want to talk so much about the issue of database because it's a key part, but it's probably going to require you to um, bind a database to your deployment, depending on the environment you choose to use to deploy. You can deploy, for instance, as a Azure Web Apps, where you can probably use different, if you need storage, you can use either the Azure blobs, or you can use like just a simple, database server to really persist your data. And from your code, at every point in time, you run a GET request to the database to fetch any data that will be of use to the user request. So that's in a use case whereby you have data that an action from the user would fetch the data and generate the plot. Um, in terms of how you do that within Dash, it's straightforward. Is a callback that will listen to the user input, and it will trigger a function that will fetch the data from the database and output whatever plot in the designated output figure. So it could be a bar chart, a scatter plot. You will have really put that scatter plot where it should be in your layout, and you give it a right ID name. Your callback will listen to any input that will trigger the function that will generate the plot and return the plot output to the figure that you have defined as the output, essentially. So you need to understand whether you need to persist data, because if you need to persist data, well, you could try to use maybe the same directory, but most times it doesn't work that well, because if your data volume is too much and you want to keep it as part of the assist file or the asset of your application, your deployment may not really run, because if you run out of memory, you probably will run into that issue. Or the best case, the productionalized way to have it is to have like a database binding, where all those data will be actually persisted, and you can just run a GET request to the database to fetch it, and it will, based on the user trigger, present your result. So it's more around the way you design your app and what the expectation for the chart you want to. But let's say your chart, for instance, is going to be based on data that I just get an input, I run a function within my code, and that function is data I want to plot. Then that's easy. You don't need a database. So let's say I have an equation that gives me X and Y, and I just get a parameter from the user, and I can generate both X and Y within my code and plot it. Then I don't need a database. I just stay within my code, generate it, and plot it in real time. So I don't know if that makes sense to you.
All right, awesome. Good answer, Michael.